Hello everyone, in this video we're going to be talking about something called bioaccumulation. And we're going to look at it specifically in food chains. So let's first of all start with a definition of what we mean by bioaccumulation. So biological, and accumulation means like a build-up. So this is a build-up in something biological or a biological system. And in this case, in food chains, it is, and we'll just make a little note underneath as well, it is a build-up of either toxins or poisons in that food chain. So it's a build-up of toxins. I'll put food chain / biological systems. Let's keep it general, but that's what we're looking at. Now, the best example of bioaccumulation that schools tend to refer to is that of the use of a pesticide known as DDT. So it was widely used in the 50s and 60s, and pesticides are chemicals that are designed to kill pests, things that would damage crop and affect the yield. But what they found is that this DDT was running into waterways, it's getting leached into waterways and having a really devastating effect on birds. Now you may think, how would it run into water and then suddenly affect birds? And it's because of this bioaccumulation. So let's start at the bottom of this food chain that I have on the side. This here, at the very bottom, is something called phytoplankton. Now what I'm going to do next to each one is look at the parts per million of DDT in these organisms. So I'm going to use this pesticide DDT as an example of how bioaccumulation happens in a food chain. Basically, if we imagine the DDT running into the waterways, and it would be absorbed by some of this phytoplankton. So what we're going to do is we'll look at DDT in parts per million. We'll just call that ppm. So I'll write in red the name and the parts per million in blue. So let's say this is about 0.001. So what we're saying here is that we're imagining DDT, this pesticide, run into waterways and is absorbed by this phytoplankton. Now a small bit of this chemical in the phytoplankton doesn't necessarily harm it, but if we have something that is consuming a great deal of that phytoplankton, then that concentration of poison can build up. So this is zooplankton. It's like animal plankton. And what we see is that this DDT parts per million value can raise to about 0.03 ppm. We'll put those there, ppm. So we have a certain concentration of DDT in the zooplankton. Now if we go higher up, we can see we've got some small fish. So some small fish would eat the zooplankton with that chemical inside of it. And if you have one small fish, let's say, eating multiple zooplankton, then you can see that the concentration of that toxin would build up. So we end up with something like about 0.15 parts per million. So we can see this concentration is slowly going up and up. The small fish are eaten by much larger fish, and we can get a parts per million of size 1.4. And then finally we've got this bird at the top, the osprey. This is, so we'll just put large, we'll call this the large bird at the top. Now, what we actually saw, so when DDT was being studied and the effects looked at by environmental groups, what they found is that it was building up from the phytoplankton then into the zooplankton, then into the small fish that ate that, then build up in the large fish that ate the small fish. And then they noticed that the number of large birds was decreasing. Large birds were eating the large fish. Now, if it ate a small amount of fish, it would have had a certain amount of poison in, but then if it eats multiple fish, that level of poison would have gradually built up. And what they found is that the number of wild birds was massively decreasing. They were also producing shells that were very, very thin. So the shells that we're referring to here, the eggshells that these birds were producing were very, very thin and so were not sustainable. And also, this DDT had rendered many of these wild birds infertile, so they weren't able to go on and have offspring. And the concentration would get so high that it would actually just kill them. So in the large bird, we could get concentrations of up to 20 parts per million. So what I've been recording there is the DDT level. And this ultimately highlights this bioaccumulation, this build-up of chemical, typically toxins when we think about it in key stage 3 and 4, toxins in this food chain or the biological systems. So accumulation of chemical, and you get a gradual increase in concentration in the consumers as they are essentially eating things below them. So this level of DDT gets more and more concentrated up to the point where we get to the top of the food chain, this large bird, and then what we actually saw was a significant biological effect on them. The eggshells were thinner, they were being made infertile, and we're actually just killing them, and their numbers were declining. DDT, as of now, DDT and the use of this pesticide has been banned largely, but it's a good example to use when we're looking at this phenomenon of bioaccumulation in food chains. Okay, hope all that helps.